Hello and welcome to the right triangle trig video. In this video, we're going to be going over some things you probably already know, like your Pythagorean theorem and your SOHCAHTOA, but also finding angles, side lengths, as well as our three other trig functions. So let's get started. So when we're dealing with right triangle trig, we obviously have a right triangle, something like this. So we have a right angle here. And when we're dealing with the side lengths, there's two different ways we may refer to them. If we're dealing with our Pythagorean theorem, we'll call these A, B, and C, where C is your hypotenuse, or your longest side. And our Pythagorean theorem says that A squared plus B squared is equal to C squared. Now that C right there, that's always going to be that hypotenuse, longest side. It's across from that right angle. That helps us find other side lengths. Now this is our hypotenuse, but what can we call these other sides? Well, we're going to refer to them in terms of our angle, theta. So just as a side note, that circle with the line through it, that is the Greek letter for theta, kind of like pi, it's another symbol. So this is theta. It's going to mean our angle. Now, when we're looking at theta, it's going to give A and B some proper sides. If we look all the way across our triangle, that's going to be our opposite side of the triangle. And then our last side would be our adjacent side, or next to our triangle. Now, if you're thinking opposite, adjacent, and hypotenuse, that seems kind of familiar. I'm hoping it does. I'm hoping it reminds you of SOHCAHTOA. Now, SOHCAHTOA is just a memory trick that we use to remember our different functions. There's three different trig functions. You can find them on your calculator, but they are sine, cosine, and tangent, and they are just ratios on a triangle. So the SO means that sine of our angle theta is equal to O over H, or opposite over hypotenuse. The ka portion of the SOHCAHTOA means that cosine of our angle theta is equal to A over H, or our adjacent side over our hypotenuse. And then the TOA means that tangent of our angle is equal to the OA, or the opposite, over the adjacent. So these are all things that we've learned before, AGS 2, possibly in AGS 3. We've dealt with these before. Just keep in mind, when we're solving for theta specifically, we're going to use an inverse, or like the little piece with the -1, to find an angle. So an example of that might be if you have, let's say, sine of theta is equal to 1/2. Well, in order to get theta by itself, you would use sine inverse on both sides and get sine inverse of 1/2. And then plug that into your calculator and you would get that theta is equal to 30 degrees. Another comment on here, we won't have to change our settings, I think, until the next unit, but just make sure your calculator is in degrees. Now, there's many settings on the calculator, but two of them are degrees and radians. I think most calculators are degree by default, and I can show you how to check that, but just make sure your calculators are in degrees or else this is going to mess us up. Anyway, we have our three trig functions that we know, and you might have asked yourself in the past of, well, what if, like, hypotenuse is never on top? What if the hypotenuse is on top? Well, that's where we get our other three trig functions from. They are the reciprocal, or the flip, of sine, cosine, and tangent. The first one being called cosecant. So cosecant, we shorten that to CSC of our theta is equal to the flip of sine, or hypotenuse over opposite. You can also think of this as 1 over sine of theta. So that's the reciprocal, or that flip. The flip of cosine we call secant, or we shorten that to SEC. Of theta is equal to the flip of cosine, or hypotenuse over adjacent, which you can also think of as 1 over cosine of theta. And lastly, the opposite of tangent, or the reciprocal, we call that cotangent, which we shorten to COT. If theta is equal to, in this case, adjacent over opposite, or 1 over tangent. Now, it's going to take a little while to get some practice, realize what's the reciprocal of what. The way that I think of it is that each pair, one of them has to start with a C. You can't mix a C up with another. So we have sine and cosecant, we have cosine and secant, and we have tangent and cotangent. So each one of these pairs is a C. The C's do not match up with each other. So this is all the information that we need to know. Some of it is new, hopefully not all of it. But let's go over 3 different problems from our Go formative, just from the worksheet, not from the actual questions I'll have you do, just so we can practice finding angles using the Pythagorean theorem and dealing with our trig functions. So let's get started. So when you're looking at the worksheet, I'm going to start with what says problem number 31. So problem number 31 says that cosine of theta is equal to 2 pi over 3. So the first thing that we want to do is we want to build our triangle, find the missing side. Well, I know that if we have a triangle, right triangle, can be facing any direction. Here's my right angle. I'm going to put theta down here. You can put theta up here. That's totally fine. You're still going to get the same answers for your side, so don't worry about that. But we know that theta, or pardon me, cosine is adjacent over hypotenuse. So if we were to look at our triangle, it'd go, okay, well, all the way over here is my opposite side. Hypotenuse is my longest side. Adjacent will be the one at the bottom. So I can say that, okay, that bottom side, my adjacent side is 2, my hypotenuse is 3, and now I need to use my Pythagorean theorem, or my a squared plus b squared is equal to c squared, to find that last side. So I'm going to say that I don't know that top one, so we'll just call that a squared, but that we can add that to 2 squared is equal to 3 squared. So remember that hypotenuse is always your c. So from here, once we start solving, we're going to have a squared plus 4 is equal to 9. I'm going to subtract 4 on both sides and get a squared is equal to 5. Now to get a by itself, I'm going to take the square root of both sides, and I get a is equal to the square root of 5. Leave this as your answer. So don't give me the decimal, give it to me in the square root. So we have our last piece. Okay, so we've built our triangle. Now it wanted me to say, hey, since this is what we have for cosine of theta, tell me, what is sine of theta? Well, I know that sine is opposite over hypotenuse. And now that we have our opposite side, I can say that's going to be the square root of 5 over my hypotenuse of 3. So that's my second piece. I've built my triangle, I've found the answer to my question in its whole entirety of the trig function. But the last question asks for what is theta? Well, we're going to use our calculator for that. You'll notice that there's only a sine, cosine, or tangent. So you might use the equation that you're given, you might use the one that you've already found, but choose something that is either sine, cosine, or tangent. In this case, we have both sine and cosine, so we can use either. However, I'm just going to stick with the cosine because that one doesn't have a square root in it. So when we're dealing with our angles, if we have cosine of theta is equal to 2 over 3, I'm going to use cosine inverse on both sides. And you know what? I'm actually going to erase this so we have a little bit of space. So just like we would multiply something on both sides or add something to both sides, I'm going to apply cosine inverse to both sides. Now you don't have to do this every time, I'm just doing it for this first example. And since we have cosine and cosine inverse, it's kind of like multiplying and dividing. They cancel each other out. So we're just going to be left with that theta is equal to cosine inverse of 2/3. So once you put that in your calculator, I'm going to round to the just first decimal place for my angles. We're going to get theta is equal to 48.2 degrees. And there you have it. So this is our third piece that we wanted to know. So for the questions in the Go Formative, I want you to build me the triangle, find the solution to the trig function it was asking for, and then actually find me the value of theta. So that was for 31. Let's try 30 now. And I'll do that over here so we can kind of copy our steps. So this one tells me that we have secant of theta is equal to 5/3. So I'm going to go back, I'm going to take a look at what we had before, and I go, oh, okay, secant, that was the flip of cosine, or this means that we have hypotenuse over adjacent. So really similar, just flipped. So this is going to be my hypotenuse over my adjacent side. So when I draw my triangle, here's my right angle, I'm going to put my theta down here. My opposite side is going to be over here. I don't know that one. Here's my hypotenuse. Here's my adjacent side. Now in this case, our hypotenuse is 5 and our adjacent side is 3. So it's actually the same amount of information that we had for problem 31, just shown to us a little bit differently. But now, the steps are still the same. We're still going to use Pythagorean theorem to solve for that opposite side. So we'll have a squared plus 3 squared is equal to 5 squared, which becomes a squared plus 9 squared is equal to, not 9 squared, just 9, there we go, is equal to 25. And I'm going to subtract 9 on both sides and get a squared is equal to 16. Now to get a by itself, I'm going to square root both sides, and we get a is equal to 4. So this answer is a little bit nicer, and this tells us that our opposite side is 4. So that was our first piece, finishing our triangle. Now this problem specifically was asking us for tangent of theta. And remember, tangent is opposite over adjacent. So in this case, our opposite side is 4, and our adjacent side is 3. So we can say that tangent of theta is 4/3. Now, on our calculator, when we want to find an angle, we don't have a secant button, so I'm just going to use this tangent. Now, you can show the steps that I did in problem 31 in red if you want, but you do not have to. For here, I'm just going to say I'm going to tangent inverse both sides and end up with theta is equal to tangent inverse of 4/3. You can usually get your inverse button by pressing second on your calculator and then the tangent button, or second and then cosine, kind of whatever you're looking for. But that's kind of it. Once we plug that into our calculator, we get that theta is equal to 53.1 degrees. And there you have it. Let's try just one more together to see if things can get a little bit complicated. So I'm going to scroll this up just a little bit. There we go. And we're going to take a look at problem number 26. Now 26 says that cosine of theta is 2/3. And I'm just realizing this is the same setup for 31, so we already know a bit about this, right? This is going to be our adjacent side over our hypotenuse. So when we build our triangle, there's my right angle, there's my theta. All the way across is my opposite side, my hypotenuse is the long side, my last one's the adjacent side. And we know that our adjacent side is 2 and our hypotenuse is 3. So to solve for our last side, we're going to use our Pythagorean theorem of a squared plus 2 squared is equal to 3 squared, or a squared plus 4 is equal to 9. I'm going to subtract 4 on both sides and get a squared is equal to 5. And to get a by itself, I'm going to square root both sides, and we'll get a is equal to the square root of 5. Now I'm realizing that in all three of these examples we've been looking for side A. That will not always be the case. Sometimes you'll have to look for your hypotenuse. So just make sure you're plugging in your sides where they appropriately go. So again, this is the same as problem number 31 as above. We can see that, but it's asking for a different ratio. Now it's asking for cosecant instead of sine. So we're looking for cosecant of theta. Well, remember, cosecant, if we go all the way back up to here, cosecant was the flip of sine. So we want our hypotenuse over our opposite side. So we want our hypotenuse over our opposite side. And that's going to give us 3 over square root of 5. Problem is we don't want the square root in the denominator. We have to rationalize it. So to rationalize it, it means we're going to get the square root out of the denominator by multiplying the denominator by itself, square root of 5. Because square root of 5 times square root of 5 is square root of 5. Or pardon me, is just 5. But what we do at the bottom, we have to do at the top. So we end up with that cosecant of theta is equal to 3 times the square root of 5 over 5. And so we found our trig ratio, something that is special. It's a little different than what we're used to. But now that we found that, our last thing to do is to find the angle. We don't have cosecant in our calculator, so we're going to use cosine. And again, when you have cosine of theta is equal to 2 over 3, you can use cosine inverse on both sides and get theta is equal to cosine inverse of 2 over 3, and this is going to give you the same thing as it did last time in your calculator, which is that theta equals to 48.2 degrees. So that's just a few problems that we'll be practicing in class together. Rewatch this video if you need to. Let me know if you have any questions, and I look forward to seeing you in class. Now, oops.